starts with their equivalence. Okay, if we have the distance is equals to velocity times time, we have also the equivalent in angular motion. It's going to be displacement times the angular velocity times time. Now, if we have also, for example, the distance like that is equals to VOT plus 1 half GT squared. We have also the equivalent of angular displacement is equals to the angular velocity, okay, times time plus 1 half angular acceleration alpha times t squared. If we have also a final velocity is equals to initial velocity plus acceleration times time is equals also to the final angular velocity is equals to initial angular velocity times angular acceleration times t. Okay. Now if we have also Vf squared is equals to Vo squared plus 2at is gonna be final angular velocity which is the power 2 is equals to initial angular velocity which is the power 2 plus 2 times the angular acceleration. D is angular displacement theta. Okay, get the point. And the last but not the least is through the instantaneous displacement. So we have, okay, still again displacement where D is equals to 1 half times bracket the whole thing of the final velocity plus initial velocity, okay, times time. So the equivalent here also is going to be angular displacement theta is equal to 1 half times angular final velocity plus initial angular velocity times time. So we have 4 equations in a row, or 5 equations in a row. So we have here linear, and here we have angular. This is kinematic linear equations, kinematic angular equations. Okay, you got the point. Here involve angles and angular. Here not necessarily, plane only. Okay, here the other one. Okay, even though this is also plane, but when the topic reaches to projectile trajectory, it will create a curve like that. If you kick the ball, if you drop the ball, if you throw the ball, it can produce a parabola, circular or curvature shape somewhere along the way. You can also apply this using components of horizontal axis. That's what I mean. But here is exclusive talaga siya for angular, radian, blah blah, chuba chuchu. Okay, you get the point. And then the formulas here you can feel because the problem is always telling you radian like that. Radian, for example, angular velocity. Angular velocity will be radian per second. You will feel that it's gonna be an angular motion topic when you solve the problems in the future. Okay, like that. And then the angular acceleration will be radian per second squared, like that. Okay, then angular displacement theta will be in radian. Okay, you get the point? Oh. So the introduction of radian will be helpful here. Radian. Okay, meaning to say, radian is the basic unit of angular motion. Radian. Okay, through this you can create a new definition because it's very obvious here. When you substitute the radian in when you have the angular velocity, the radian will be there also. When you put the formula of angular acceleration, the radian also will be there. And if you put the angular displacement, the radian also will be there. So we can say, by definition, radian is the basic unit in angular motion. Okay? So you can create your own definition of what is really a radian. Okay? Through understanding the formulas. Now, if we have like this, so makaingon po tagnay mga revolution, chuba chuchu. Because this is circular, right? Circular. Gusto mo define circle like this. Oh, ganon. So this is one revolution. Oh, di ba? It's gonna be 360 degrees, mga kapatid, kung hitad. Okay, if you will completely turn into a circle. Okay, now the half is gonna be, this is now a little bit of trigonometry. Gonna be 180 degrees, right? And here in the perpendicular it's gonna be 90 degrees Di ba, mga kapatid kong hitad? Yup. Ganun siya. Di ba? We'll start here. Okay, here this is, to make it short, we will draw an imaginary line. Okay? To make it understand well. So this is y-axis, perpendicular, and x-axis, horizontal. Right? If you start on the plane without moving, so you have a 0 degree. Because you did not rotate yet by common sense. So 0 degree. Ganon. Then if you try to move perpendicular from the horizontal, it creates a right triangle. Right? 90 degree. So this here is 90 degree. Then move. Here, the opposite of 0 degree will become now 180 degrees. Okay, because you add 90 degrees and 90 degrees here in the second quadrant, then it will become 180, right? Oh, first quadrant, second quadrant in algebra, third quadrant, fourth quadrant. So one quadrant has a 90 degrees already, plus 90 degrees in the second quadrant, it will become 180 degrees like this also. And then also the opposite of 0 degree. Now, tuyok siya. Here, the opposite of 90 degrees will be adding also another 90 degrees, right? It will become 180 plus 90, 270 degrees, right? And coming back again, which is to the original point, which is 0 degrees, it will become now to 360 degrees. Because it rotates, and this is not the revolution. Okay? Revolution, just like our planet Earth revolve around the sun, along with the other 8 planets in the solar system, in the universe. Something like that. So things like that. Okay. Now, here guys, we are not concerned with the rotational movement by its own. Okay, we are only referring to how it revolves. Because it's another also story you will say, how they rotate upon revolving. Okay? Revolution and rotation is not the same. Okay, when you say revolution, you will revolve 160 degrees in a particular reference. But when you say rotation, the object itself is rotating before doing the revolution. Like me, I will get, this is a circle, I want to revolve now. Me, if you do rotation, me also will rotate myself before going to revolution. That's the process in the universe. Our planet Earth will rotate, and then at the same time we go to the revolution. That's why one revolution in the entire orbit causes 365 degrees, 365 days, or 366, it depends on the leap year or whatever. Okay, 366 is the leap year and the normal will be 365. That's mean one revolution of the planet Earth. The same like this. But in this topic, we are not considering the rotation. You get the point? For example, if there's a particle here, electron, proton, neutron, the electron and proton and neutron will just rotate, rotate in this particular direction. But themselves will not. Hindi mo tiktoik sa kagalingon ba while revolving on the circular path. Diba it's totally different when you try to picture out. Okay? If it is the case that the Earth will just revolve, it's very easy to attain the 1 year. Meaning to say, while it reached to its revolution, they rotate by himself, the Earth. But that concept is not applicable here. Okay? It doesn't mean it will rotate by themselves. Okay? Whether it is a car, an object, a ball, or let's say name all the kind of balls. Football, volleyball, so this is more on the motion. If we talk about the balls, the pendulum, like the problems in physics, usually ano lagi siya guys, per me, object, chuba, chuchu, okay, masabtan man mo, agi siya ni-rotate at first, igo ka siya ni-revolve, okay, ganon. So, in here, since we are talking of the revolution only, so we can say pala mga palangga, kung itad, charot. Okay, so we will say nga, it's also carrying the principle of frequency. Okay, so frequency is equals to cycle per second. Okay, meaning to say, one cycle is equals to one revolution. Ganon. So you'll say, 1 revolution per second is 1 cycle per second. Let's say, the one circular path or shape is 1 cycle. And if you revolve 1 time there, that will be 1 revolution per second. And that is your frequency. Okay, in terms of objects moving. But that is not true for the particle, particle, in a really scattering and radiated, because that is oscillations per second there. How it penetrate over the time, how it radiate over the time, or how it oscillates. Meaning, it will do a little bit of vibration when you hit the wall or material. It will move something like that. It will not stick immediately. It will move a little bit, just like a little bit of vibration before stop the movement. Oscillation. Like that, before it will stop. Oscillation per second or vibration per second. It's also the unit of frequency. It depends on the topic you are trying to discuss. Here we're discussing the big objects, materials, so we'll say revolution per second is also the frequency. Meaning kasi palagay sa mga palangga, kumitan, revolution per second is also the hertz. Here, it doesn't matter whether it is an object, a particle, or whatever, as long as it is a revolution per second, cycle per second, oscillation per second, vibration per second, blah blah blah, so on. So that is automatically the hertz. Okay, the frequency. In terms of electricity, because we are referring to the electrically charged electrons, get the point, electrically charged, that will become also the frequency. How it will be oscillated somewhere along the way in the wire or in the cable. Movement. Ganon. It will vibrate and it's inside the internal wiring. That's why it's good. Oscillation per second is equal to frequency. But it's not true here, because we are not dealing here with particles, electrons, protons, neutrons. Meaning kasi, in this topic, we are looking in the macroscopic scale. Macro. Okay, not micro. Micro is elementary particles, subatomic particles. Here, macro. So it is expected, it's very easy to solve in this topic. Why? Because we can clearly see in our naked eye. We can visualize what will be happening after 2 seconds, after 5 seconds. But this is not true for the particles, because you cannot predict this atoms, molecules, ions, because you cannot see that by your eyes. There's a clear difference unless you will use the technology, like a macroscopic technology or a spectrophotometry technology to see what's going on. These particles behave in a certain spectrum, like that. Okay? You get the point. This is gonna be like that. So, isujud siya ang mga smallest particles or tiniest particles compared to the macroscopic scale. Okay? So, you should remember these formulas also. Very, very important, especially if you're taking the board examination. Okay, for physics. Okay? Like that. Get the point? Ganon. Any questions so far for this particular topic before we're going to calculate some problems in regards to angular motion or kinematic angular motion? No questions so far, so you can share this also to your friends, these formulas and equations, and you can also subscribe to our channel if you want, and then you can click the notification bell for some news updates. Bye. See you tomorrow. Bye. God bless everybody. Stay safe. Nakakaloka.